All right, let's start our class. Let me share my screen. So yesterday we were discussing about normalizations, normal forms, right? Today we will finish that concept. So yeah, yesterday we were discussing that if we have any denormalized data, how we will convert that denormalized data into normalized thing, right? We discussed about 1NF yesterday. Let's discuss about 2NF and 3NF. Then our this concept will be finished once when our data converted into 3NF. That data, it will form like normally whatever databases or whatever tables we are using, in daily basis, like what how Maven movies database or how Maven movies tables look like that we will convert the complete data into that form. Okay, so now let's see. As I said, for let me share my complete screen first. This is one of the data set. Okay, actually this is the sales data set. Let's see on this data set only, but for the first, just to make you understand about 1NF, I used this data. Okay, this is basically, I will explain about what are all the columns we have, but first, yesterday we saw this data, right? Suppose this is small table, we have only 3 columns here, but usually denormalized data, in the sense, we will have like this. We will have lots of rows, we will have lots of columns, like this. Okay, so suppose if we imagine this as our denormalized data, I said we have 3 normal forms. In first normal form, I said if we have 2 rules. Okay, first rule is every column must have one single value, and the second rule is, I hope you can see my screen, right? And the second rule is each row must be unique and not mandate to have a primary key. So first we have data like this, correct? Okay, first we have a data like this, and after that what I did to to satisfy the first rule. First rule is stating every column we should have only one single value, right? That's the reason. What I did, I splitted this column. In the course column, I have multiple courses. I splitted that column. But as I said yesterday, basically we will split by using any of the tools. Okay, not manually. We don't work on manually. But for now, let's forget about the tools. Just try to understand about the concept only. Two ways, there are 2 ways for splitting. If I split by column also, basically first rule will satisfy, but the concept here is, as I said yesterday, if we have many courses, suppose if I have 4 or 5 courses here, and for student if I have only 2 courses, for one student if I have 5 courses, I should keep on writing like course 1, course 2, course 3, like this, right? As we saw yesterday, for remaining students we need to fill with all the null values. So we will avoid splitting by column. We will split the values in by row only. Okay. I hope this is clear for you. Correct? Whatever we discussed yesterday. So yesterday what I did, I splitted in row. That means first I wrote one Priya Excel. For the next, again I use the same data and I given Tableau here. Right? This is the details of Priya. This is the details of Ram, like that. Right? After splitting this in in the row level data, after splitting this, if you can see, my first rule is satisfying, that is every column must have one single value. Here if you can see this data, in every column we are having one single values only, correct? And the second rule is each row must be unique. If you can see, they are saying each row, not every column, not column. They are saying row. So we need to just check with the row. Okay, no data is repeating in the row. Correct? We are having some unique data only in the row and not mandate to have a primary key. Okay, that is again one more rule. Of course, if we had to create a primary key, we need to create a primary key. Basically, we will create a primary key on IDs, as you all know. Here in SID, as we have many duplicates, we cannot create a primary key, right? So that is what in the rule also they are saying not mandate to create a primary key. So this rule is also okay. Basically, these two rules is satisfying for my data, correct? Am I clear so far?
Yes, ma'am.
Yes.
Okay, so I can say this is my denormalized data for now, and I converted that data into this form, and I can say now my this data is in 1NF. Okay, now I need to convert to 2NF and 3NF, but we are not working about 2NF on 3NF on this data. Whatever data I shown you on this data only we will work. But before getting into that data, just understand one more point here. See, I said in the second rule, not mandate to have a primary key. Okay. Previously, whenever I discussed something, whenever I discussed about keys or somewhere, I didn't remember where I said, but I said that we have something called as candidate key. Did you remember anyone? We have something called as candidate key. That means what is candidate key in the sense, basically what is primary key? We all know. Whenever we define primary key on any column, it will not allow null values and duplicate values, right? Whereas candidate key in the sense, if we are defining two columns as a primary key, in any table, if we are defining two columns as a primary key, that that columns or that basically that term we will call it as candidate key. That means in this data, observe SID cannot be my primary key because as I have duplicate values, right? This S name also cannot be the primary key, and again we don't usually prefer using names, right? In for to create a primary key because we can have same names also for two persons. So in this way, if in such tables we will use candidate key. Candidate key in the sense, whenever we are using, if we are using the combination of two columns, whenever combination of two columns is act as a primary key, okay, that is called as candidate key. Okay, that means here two columns can act as a primary key. Okay, not the single column. The concept is same again. I mean, basically why we will use primary key, whenever we declare primary key there should not be null values, something like that, right? So candidate key in the sense, there we should use the combination of two columns. In this example here also, I cannot define a primary key, but I can define a candidate key. What columns can act as a candidate key in this table in the sense, SID course. Okay, either SID comma course, I can use this two columns as a candidate key. That is, combination of SID and course column should be unique. It is unique, right? If I join, if I need to see the two tables, the combination of two values to consider it as a unique thing. That means combination of SID and course in the sense one Excel, right? Next one Tableau. I have one here, but basically what I am getting here, one Excel will be one thing and one Tableau will be my second value. This complete two values we are considering it as a primary key. Any doubts,
Yes,
Mahesh?
they,
Yes,
uh,
yes, please.
as we compare the only the row value, we can define the student name also, name also candidate key
Yes,
only.
yes, we can. That's what I'm saying. We can define many candidates key in any of the table. In this table, we can decide SID and course name, or else is name, student name and course,
Yes.
like that. Okay. Next point I was about to tell that in any table we can create many candidate keys. The thing is that whenever what we need to use two columns over there, and the combination of that two columns value should be unique. That's it. If here SID and course, in the sense one Excel is unique, one Tableau is unique, two Power BI, two Tableau, like that, the data will be unique. Again, we can also create a candidate key, another candidate key in this table stating S name and course. Priya Excel is unique, Priya Tableau is unique, like that. Okay. That is about the candidate key. Did you understand the concept of candidate key, everyone?
No, ma'am.
Is it no?
No.
Okay. See, basically, you know what is primary key, right? Primary key in the
Yeah.
sense,
Unique and not null.
yeah, unique and not null is the primary key. So at that time only, somewhere I said we will come across another key called as candidate key. Candidate key is nothing but, in any table, if we are unable to, create a primary key. In this table, if you can see, I cannot use SID as a primary key, right? In that situations, or else in some tables, we can define a candidate and a primary key as well as a candidate key. It's no problem. But what candidate key is actually means, if if we consider two columns together, okay, whenever we take any two columns, that two columns together should act as a primary key. I mean, what primary key will do, all that things, the same the same functionality only it will also do, but here the combination of, there should be the combination of two columns. That means to create a candidate key, here I will say candidate key of SID comma maybe course. If I say like this, if I create candidate key of SID comma course, in the sense the combination of SID and course, these two values should act as a, these two columns together should act as a primary key. The values together, the 1 and Excel are the values of SID and course, right? So this together we will consider as a primary key. Like, however, we will see only one column in primary key. This time we need to see both the columns. See, one Excel is
Primary
unique,
key or
one Tableau
candidate
is,
key?
that's what the functionality, the candidate key is doing the same functionality of a primary key only. Here you can see I wrote combination of two columns. Whenever we are taking any combination of two columns that is acting as a primary key, that columns, that functionality is called as a candidate key. Basically, it will act as a primary key only. But when you see in tables, if we need to define primary key, we need, we have one rule that in one table we will create only one primary key. We know, right? And whenever we are creating a primary key, definitely we should, we will use only one column. Like, for SID column only I can create a primary key, right? So in the same way, if I want to create a primary key, I will write it as primary key of SID, oh, of SID, like this. That means only one column I'm using, and on that one column only I'm creating the primary key. On whatever column I created the primary key, in that column it will not allow null values and duplicate values. Basically, that data should be unique or not null, correct? In the same way, if I define candidate key, something like this, if I define, whenever I want to define, I am about to define candidate key, I will use two columns, the combination of two columns. Definitely we need to use two columns, but again we will use the word called candidate key, but the combination of these two columns will do the same functionality of primary key. That means here I am considering SID and course, is two columns, I'm creating a candidate key. What it will do, SID and course, two columns together, where is, these two columns together act as primary key only. While defining, we will use candidate key. I will define candidate key of SID and course, but the functionality it will use primary key only. That means one, this is SID and course together, both the columns will act as a primary key here. This both columns together, if we observe the values of both the columns, it should be unique, it should not be null, like that. Did you got my point now?
Yes,
Sure.
ma'am.
Yeah. So here we will mention basically two columns, and these two columns, if I see here, my SID is 1, my SID is Excel. This now we are not considering one data as unique. Okay, we are considering two values as unique, like that. And we can create many candidate keys in one table. In this table, I can create SID and course as one candidate key, or else SNAME and course as one candidate key. I can use any columns, but I need to use only two columns, whatever columns I'm using to create a candidate key. Collectively, that both columns data should, should follow the primary key rules. I hope this is clear for you, everyone.
Yes, ma'am. I have one question.
Yes, please.
Ma'am, let's suppose if we have multiple number of columns, here it is 3, so candidate key is combination of 2.
Yeah, we
Right?
will see that. We will see
Okay.
that. Next, we are going to solve this one only. At that time, you can understand. Okay. For now, I hope how we will, what is first normalization form, you got some idea, correct? And you got some idea about candidate key. Okay. And I said first, first our data will be in the denormalized form. We need to convert the denormalized form into 1NF, then 2NF, then 3NF. After whatever output or whatever table we will form, we will get after performing 3NF, that tables will be look like normalized tables. Normally whatever tables we are working now, for now, in Maven movies, like that we will get. Okay. So I hope 1NF is clear for you. Let's see on this data now. Okay. As you know, here splitting the values and we have multiple values, this concept, if I directly start explaining on this data, it will be completely confusing. That's the reason I explained 1NF on this data again. Now this is, I have some sales data here. Okay, I have many columns, if you can see. Okay, I have many rows. But to make you understand about all the concepts of denormalization, what I did, okay, I thought someone texted me. Okay, fine. So I'm saying this is my denormalized data, and I have many rows in this. Almost we have 2824 rows in this. But to understand clearly, I just took some rows. I just made this data into like this. I, I just reduce the rows. The columns are as it is. Again, I reduce some columns also, like, I have quarter ID, month ID, year separately. No need of this like that. I just removed some 3 to 4 columns, and I made out of this data only, I made this data, so that if we work on this, you can understand clearly, right? We have only 9 or 10 rows over here. Okay, now let's first try to see the column names what we have here. This is order number. Basically, this is sales data again. This is order number, quantity ordered, sales, order date, status of that order, whether it is shipped, in progress, like that. Okay. So we have product code, product name, product price. This is basically the product price. That is for motorcycles. Just this is again completely sample data. Okay, don't just try to understand the concept. For suppose this motorcycles, if my price is 95 rupees, okay, they ordered 30. Quantity ordered is 30. Okay, so 95 into 30, my total sales will be 2850, something like that. I hope you understood. This is, each product wise price. Okay, for every product what is the price, and this is the quantity, number of quantity they ordered. So this is the sales I got. Okay, clear? Next, I have customer name. This is phone number, address line 1. Basically, this all belongs to the customer details from here. Customer name, phone number, address, city, state, postal code, country, up to here. Okay. Next, I have some information about delivery person, last name, first name, deal size. Okay, these are all the columns. Now let's see. Let's try to create 1NF, 2NF, and 3NF out of this data. Okay. If you observe here, I have two columns. Okay. In these two columns, I'm saying product names up to here. I have, single values only. But here I'm having trucks, buses, right? That is, this customer names, you can see this is something like maybe the company names. Okay, so this company has ordered trucks as well as buses. Okay, and they ordered 33 and 24. That means they ordered 33 trucks, 24 buses. So the total cost is like this, 3300 and 1920. So basically in this two rows, what happens, they ordered two products and everything is in one. I mean, they stored the data in one row only. Correct? Did you got my point?
Yes, ma'am.
So now let's see, this is a kind of denormalized data. Now first we need to convert this into the 1NF. Let me rename here as 1NF. Okay, and I'm just copying. Okay, so just to save our time, yesterday only we wrote 1NF rules, right? Okay, this is our 1NF rules. Correct? I hope, can is my words visible for you?
Yes, ma'am.
Okay, 1NF in the sense, these 2 points. Every column must have one single value and row must be unique, no need of primary key. So here, what I need to do, first I will convert this data into 1NF. For that, if you observe, I have only in these two rows, I have multiple values, trucks, buses, like this, I have multiple values. Basically, I need to split this data again into the row level. So I'm just copying my complete data. Okay, I'm copying everything. Here, I'm pasting it. Okay, let's leave this customer details like that only. Okay, this is my data. Now I have these two columns. I need to split this data into row level. So what I can do, simply I will just copy this entire thing. As this is Excel, I'm not using any other tools. Just I'm explaining for understanding purpose. I'm just copying this and I'm doing everything manually. Maybe I can paste that data here. Okay, and if you can see, I will just remove the first columns. I need to remove the first column here. Basically, I'm dividing it. Here I'm just keeping only 3300 and I'm keeping the first value here, the second value here. Order number will be same. Okay, quantity order here, let me keep 33 and let me keep 24 here. Okay, I'm just dividing this. I'm just dividing the uh, you know data here. That means they ordered trucks and buses, right? I'm just keeping trucks data in one row and I'm just trying to keep buses data in another row. Okay, I'm doing everything manually. Just for understanding purpose, try to see the concept here. So this is the trucks, this is the buses, and we have the combination of data in these two columns, sales and quantity orders. So I divided it. Correct? Now I got remaining data will be same. The same customer name, same customer name, order number is also same. On the same order, they just ordered two products. Okay, everything will be same. Only this three columns we need to change the data. Now previously I had in one row I had two values. I just divided the data into trucks and buses. In the same way, I will just copy this thing also and I will just divide that also. Okay, I'm copying this and I'm pasting here. Okay, in this one, right here as it is, again I'm just keeping the trucks data. Here I'm keeping the buses data. Okay, I'm just removing everything. Right? Now, if you observe this data, in every column I have only one value, right? I just split it. The same thing I did. I splitted the rows in the I splitted that columns. Whatever columns I had multiple values, I splitted that data into row level. That means here you can see I have same order number. The details are same. Only whatever data I had, I just splitted. Okay. So now I can say in each and every column I have only one single value. If I see the complete row, maybe some details are same here. If whatever we saw here, trucks and buses, I have some order number same, product name same, but here product name is different. Here buses, here trucks. So like that, in the complete row level, if we observe, the data will be unique only, right? Some columns may be same, but if we observe the complete row and if we compare with the complete another row, okay, here this one, right? If you see this one, here my order number is 104 only, here also order number 104 only, but when coming to products, I have trucks here, I have buses here. So basically, if I see the complete row, my row will be unique only. And we are saying it's not mandate to have a primary key. Okay, here also we will create a candidate key. But before that, before understanding what is the candidate key in this concept, I hope this is clear for you, right? The concept is clear for you, and I can say now this data is in 1NF. Correct? Am I clear?
Yes, ma'am.
Okay, so I can say now this data is satisfying my 1NF conditions, right? Next, I'm opening a new sheet. Okay, I just used two sheets. In this, let's understand how to create a 2NF. Okay. And guys, before that, first let me tell you, tomorrow we don't have class, okay? As I said you previously on the Saturday, I really have some personal work. So tomorrow I cannot take the class. Sorry for that. Let's meet on Thursday's class. Is that okay?
Okay, Divya.
Everyone. Shushavan, we don't have class for 8 o'clock also. I'm canceling all my classes. I have some personal work, okay? Let's see. Tomorrow we don't have class. Let's meet after this. We will meet on the Thursday's class, okay?
This
Yes, Manish.
Saturday we will be having a session, Divya. Coming Saturday.
I'll let you know by that time.
Okay.
Manish, did you have any questions?
No, Divya. As you only saying that you have some personal work. No, there is no point of asking us.
But I need to inform, no? Obviously, it's my duty to inform at least.
Yes, yes, yes. Not an issue. Okay.
Yeah. All right.
And
Yeah.
finally, we are happy that you are explaining the way of
Yeah.
explaining. No?
Yeah. Thank you. Thank you for that.
That gives us more satisfaction.
Yeah.
Satisfaction. Yeah.
Thank you. All right. So, all right. Now I can say that my this data is in 1NF, right? Now let's try to see what is 2NF. What is 2NF? And let's try to see how we will convert this data into 2NF. For that, I'm just copying the 2NF rules, okay? I'm not writing to save our time. We have some rules in, as I said previously, in every normal form we will have some rules, and you know, to say that this data is satisfying that normal form, that data should, basically follow that rules, okay? In the same way, in 2NF also I'm having some rules, okay? Okay, so basically in 2NF we have 3 points. Okay, first point is that, I hope you can see the screen. First point is that data must be in 1NF. Okay. That means on the 1NF data only, we need to start creating 2NF. Okay. First, denormalized data should convert into 1NF, and if that data satisfies 1NF only, then we can start working on 2NF. So first rule, the data must be 1NF. As we know, this data is 1NF, so we can work on this data, right? And the second rule is all the non-key attributes that we have, they must be fully dependent on the candidate key. Let me explain. So what is candidate key? I already explained. We know whenever we are taking the combination of two columns, if that columns are acting as a, acting as a primary key, correct, that columns is called as a candidate key. Now in this table, first let's try to see what can be the candidate key. As I said, any in any table we can create multiple candidate keys, but whatever columns we are selecting, that the combination of that data should be unique, right? In the same way, I can create multiple candidate keys here, but we need, whenever we are working in real time, or whenever if you think logically, we need to take the combination of a different data. For example, as I already explained, as we already discussed, this something like this kind of data in the limitations of Excel. Here also, if we see, we can understand up to here, we are having some order details only, correct? Order number, quantity ordered, sales, order date, status of that order, correct? Am I right? These three columns belongs to product tables. If end of the day, obviously we are dividing this data to make it in the normalization form. If we before only, as I already said that point, as we already dealt with this, whenever we are discussing about the limitations of Excel, I'm directly trying to convey my point here. If you observe, this data belongs to products table, right? Products code, products name, product price, correct? Am I right?
Yes.
So in the same way, if we see, this all data comes under customer details, customer name, phone, address, city, state, location. This all details comes under customer table, and we have some other data. Let's see what is that. But for now, if we see overall, we have some, different types of data: orders data, product data, customer data, like that. So whenever in every denormalized data, whenever we are dealing with any kind of denormalized data, we can understand, we can separate the data like this, like this. Like orders is different, obviously it is related to each other again. This order is also about this product only, but if we really want to divide, we will divide the data like this, right? Orders table, product table, customer table, like that. So whenever we are creating a candidate key, we will prefer to choose the columns from different kind of data. For example, I have products orders table and I have products table. So I can choose one column from the orders table and one column from the products table, like that. Even from the customer table, anything else, anything. As I said, we can create multiple candidate keys in one table. We can here also, we can create 4 5 candidate keys. Okay. For now, we can understand order number and product code. We can consider these two as a candidate key. Let me write. Order number is one column and product code is another column. Okay, these two columns. I can take these two columns, or else I can take either product number, and if we can talk about customer details, we can take any name. Customer name also we can take. Okay. Names individually we don't consider as primary key, but whenever we are combining with any other things, we can consider. We can take order number, customer name, product code, customer name, or else product code. We have something called as delivery person names here. This is that data. Where is that? This is delivery person names actually. Let's discuss about that. We can even take this column and order date, like order, what is that? First column, order number. Like that also we can take multiple candidate keys we can create, and it's completely our choice what to choose the candidate key columns here. I mean, what columns to choose to create a candidate key, it's completely our choice. Okay, here I'm using order number and product code, because if you can see in our data set, the combination of order number and product code will be unique. Definitely it will be unique. Anything, of course, customer name and order number can, it is also unique. Like that I can take anything, but for now I'm taking order number and product code as a candidate key. Okay, so I will just consider this as my candidate key, or else let me write here, or else I'll do one thing. Okay, here this two columns I'm considering it as a candidate key. Okay, am I clear?
Yes, ma'am. Please.
So this two columns I'm considering together as a candidate key. Order number and product code is my candidate key in this data. Okay. Now 2NF is stating that all the non-key attributes that we have must be fully dependent on the candidate key. That means, let me better copy this in that file only. Okay. I will keep it here also, and I will keep it here also. So I'm saying all the non-key attributes that we have must be fully dependent on the candidate key. Here I'm considering order number and product code together as my candidate key. Okay. Non-key attributes in the sense, all the remaining columns which is not a primary key and not a candidate key comes under non-key attributes. Here attributes is again something is attributes is also called as columns. I mean, columns is also called as attributes. Okay, attribute in the sense column only. All non-key columns in the sense, all the columns that are not part of a primary key and candidate key is considered as a non-key attributes. That is basically on column. Non-key in the sense we are not defining any keys on that column. Okay, am I clear this point? If there is any column in our data, if you don't have any key on that column, like no candidate key, no primary key, no foreign key, like that, if you don't have any keys on any of the column, that column is considered as non-key column or non-key attribute. I hope I'm clear. Guys, please
Yes, ma'am.
respond.
Yes, ma'am.
Yeah, so I'm saying all the non-key attributes must be fully dependent on the candidate key. So here, if you observe, what are all the non-key attributes except order number and product code, all our columns are non-keys only. We didn't define anything for now. We didn't define any primary key, any foreign key, and we didn't use these columns into candidate key also. We used only these two columns into candidate key. So all my columns are now non-key attributes only, correct? So I'm saying all that columns should be fully dependent on the candidate key. So what is this fully dependent? Let's see now. I'm saying all these columns are fully should, it should fully dependent on the candidate key. Again, in the at the bottom, if you observe, I wrote, if a non-key attribute is partially dependent, that means if it is not fully depending, we need to split that into separate tables. This is one point you can see here. In the second point, we have one rule that all the non-key attributes, this column should be fully dependent on these two columns. If it is not fully depending, then we need to split the columns into separate tables. Okay, this is the second point. What is fully dependent? How to know about it? Let's see now. Okay, so I'm saying all non-key, what is that? Non-key attributes, that is non-key columns. If we can see, all our remaining columns are non-key columns only. I didn't define any primary key, foreign key, candidate key on these columns. Okay, so we have one word called as fully dependent and partially dependent. What is fully dependent and partially dependent in the sense? I'm saying the remaining columns or the non key columns must be fully dependent on the candidate key. What is our candidate key here? Combination of order number and product code, correct? This two is my candidate key. The combination of these two columns is my candidate key. So remaining columns should completely depend on the combination of these two columns. Is that happening or not? Let's see here we have some columns, that is quantity ordered, sales, order date and status. Basically, if we really think, all these columns are of order number only. I mean, all these columns are about our order details only, right? So quantity ordered in the sense about this order number, the quantity they ordered, the sales happened on this order number, the order date of this order number and the status of this order number, correct? Am I right? This data is fully depending on the order number only, because this data we got with respect to, we have a relation. It's not relation, but we can understand this data is about order number only, correct? Am I right?
Yes, ma'am.
So this data is about order number only. So this data is basically, I can say, if any data we have that is completely about that column, we can say that is fully depending on order number. All these columns is fully depending on my order number. But here my condition is that it should fully dependent on the candidate key. That means on the combination of order number and product code together we should take. If you can see, this product code is another column of the candidate key. Whether this columns, non-key columns, order, quantity ordered, sales, order date, status, of course here whatever columns we have in this table, everything makes sense if we think with the another column. But if we really think, this data belongs to the orders table, and this data is not that depending on the product code, correct? Without product code also it is making sense. I'm right? Am I right? This data is not depending on the product code, right? It is just depending on the order number. Without product code also we can understand, because this quantity ordered is the order of the quantity of this order number. No need of the product code to understand about this quantity order, right? The sales also about this order number also only. If we use product code we can find the information, but this columns are not depending on the product code column. This is just depending on the order number. Am I clear,
Yes, ma'am.
everyone?
Then how do we know that non-candidate key easily in any other projects, Divya? This is easily we can find out it. It's somewhat difficult, no, to identify that non-candidate.
We need to work. Actually, we cannot really say, if I'm explaining you can understand, but we
Yes.
need to find out, because again it's not that finding non-key candidates is different. It's like, first we need to define, first we need to understand which columns we are taking as a candidate key.
Yeah.
Okay, basically this concept we will use whenever we are dividing only in this part only. For denormalized data, if we are planning to convert into normalized form only, we will use all these concepts. Nowhere else we will use these concepts. And whenever we are dividing like this, we will take only one candidate key. There can be, we can create many candidate keys in the table, but it's not used. We will create only one candidate key. So definitely we need to understand first. We need to decide. Again, it's our wish, we can take any of the candidate keys. But as I said, definitely by seeing the data we can understand in real time also. As we are working on that project, if we talk about movies also, now we understood that in that column what are all the columns are in tables, what columns are there, like that. If seeing that column names we can able to divide the columns. First of all, this, okay, this is orders data, this is product data, this is customer data. Like that we can understand by default, at least with some experience. Whenever we are seeing some examples of these data sets, we can divide. Once we understood the division of that, we will take one column from each table. Like, from orders table I took order number, products table I took product code, and I'm saying these two columns as my candidate key. As I said only this two, as I decided to make these two columns as candidate key, remaining all the columns in my table will, by default, it will be non-keys only. Because in denormalized, we didn't, for now, in the 2NF, we didn't define any foreign key and any primary key till now, right? In this point, till now, we didn't define. So by default, all the remaining columns will be the non-key columns only. Okay.
Okay.
So here I'm saying all the non-key columns. Here obviously it is, or it, this data belongs to orders table. It is fully depending. These columns are depending on order number only. It is not depending on the product code. Okay. If we have any such data, that data, if it is depending on both the columns, that is in the both the columns of the candidate key, if it is depending on the order number and if it is depending on the product code, in that, for that one only we will call it as fully dependent. But basically we don't have any fully dependent columns here. These columns are depending only on the order number. It's not, it's nothing to do with the product code. Okay. If you see these columns, product name and product price is fully depending on the product code. This product name and product price is not depending on the order number. It won't depend, right? This is the product name and this is the product code. This is the product price, this is the product code. Correct. It's about, to understand. It's okay for this order number, this is the product name, this is the product price. For understanding purpose, every data is related only. But we are talking about dependency. Okay. And understanding purpose, we are using all the columns, but this data belongs to product code only, right? Product name and product price belongs to this product code. So I can say these two columns are fully depending on product code. It's not depending on order number, right? In the same way, we have customer, all the remaining columns. It won't fully depend on these two columns. Customer name, customer address, or else delivery person details, deal size, all those things, it won't fully dependent on product code and order number. Okay. Now at this time, what we need to do, if the data is not fully dependent, we are call it as a partially dependent, because this order details are partially depending on the order number, this product details are partially depending on product ID, this customer details is partially depending on the order number. This customer details, for this order number only, we can know this customers, right? Like that, it's partially depending. Again, it's not fully depending. In the same way, this data also partially depending, not fully depending. So in that case, we will split them into separate tables basically. Now we need to divide this complete table into separate tables. Okay. To for this second role, for this second rule, if you can see, all the non-key attributes should be fully dependent. If it is not fully dependent, we need to divide them into separate tables. So in 2NF, basically we will divide this data. I'm just copying everything. Suppose I'm pasting here. See, just try to understand. Okay, mostly 90% you don't use this in real time, but just try to understand the concept. So now what I will do, basically, I will divide this data. Okay. In 2NF states that if non-key attributes is partially dependent on the candidate key, then split them into separate tables. What are all the non-key columns we have? These are all the non-key columns. quantity ordered, sales, order date, status. If we see about this, these are all my non-key columns. It is not depending, it's not completely depending on both the candidates key. It is only depending on the order number. So what I will do, I will split this data. I will split this data basically into another table. Okay. And I will name it as my order details table. Okay. This is my order details table. In the same way, I'm dividing this products table into another table. These are also non-key attributes, product name and product ID. It is depending only on the product code. It is not depending on the order number. So I'm just separating this table. Basically, how we did in the limitations, that one, that like that only we will follow. We will just divide all this data separately. Okay. And I can give this name as my products table. Right. This is my products table. This is my order details table. In the same way, I will convert customer tables also. I'm taking up to country only. I'm not touching this delivery person's details. Okay. I'm just taking this customer details and I am making another table here. Maybe I will do it here. Okay. This will be my customer details table. And we have at the end, we have this 3 columns, right? That is delivery person last name, delivery person first name, and deal size. Basically, this 3 columns also belongs to order details only. It is fully dependent because delivery person last name, in the sense, for this order number only, we are assigned this delivery persons, right? So basically, we will copy this 3 into orders table only. It is not fully dependent. It is partially depending on the order number. It is not depending on the product code. Okay. So that's the reason I'm splitting that also. But again, that data also belongs to order details table only. Okay. This delivery person last name belongs to this order number only. Delivery person first name belongs to order number. Deal size, I mean, about the this order, whether this delivery number is small order, whether that is big order, like that. Okay. So basically these 3 columns also belongs to order details table only. This is basically my denormalized data, the data which I have in my 1NF. Okay. The complete one. Then as it is, to convert it into 2NF, as it is not satisfying my second rule, I splitted the data into separate tables like this from here. Or this is my order details table completely. Next I have products table, I have customer details table. Now I got my 3 tables. Am I clear? See guys, at least you can understand some 80% also, that is fine. Okay. It's not that 99% or 95% we are not going to work on this, but we should have some idea. So did you got my point? What I did?
Yes, ma'am, got it.
Okay. So as all the non-key columns are not fully depending on both of the candidate key, I splitted them into separate tables. And whenever I'm converting them or whenever I'm splitting them into separate tables, I just make sure all the related table is kept in one table. Like, this all columns relates to orders. So I kept all these columns in the order details. In the same way, I kept in products, I created products table and customer details table. Okay. So now this data, these three tables, whatever I have, this data is satisfying my second rule of 2NF. Okay. Next, we have one more rule in the 3NF. That is, every table must have a primary key and it should be connected to other tables with foreign key. Okay. After dividing this data, see, step by step, obviously we need to do. First, we convert it into 1NF. After that, I make sure to satisfy the second rule. Okay. As it is not satisfying, I converted them into separate tables. Now I need to work on third rule. The third rule is that every table must have a primary key and it should connect with some other foreign key. So now I have three tables here. Okay. We should not work on this table now. This is the table which is in 1NF. Okay. Just I just copied that as it is, but this is 1NF table. I just converted or I just splitted this table into this one. Now this is my 2NF data, but again it just satisfied only one first rule, I mean second rule. Now we need to work on the third rule. Okay, third rule is that every table must have a primary key and it should be connected with a foreign key. So let's see, we have three tables here: order details table, products table, and customer details table. So in order details table, now this is my data. I need to have a primary key here. Okay, now let's forget about the candidate key. Okay, we just split it. Up to here only we had candidate key. As it is not satisfying the second rule, I splitted the tables. Now we don't consider this two as a candidate key because I just uh, you know it just okay, ignore that. So we should not consider this columns as a candidate key now. As to satisfy the second rule, I divided that data into separate tables. Now this data, now in this table we don't have any candidate key. Okay, in this table also we don't have any candidate key. Okay, candidate key is finished, that concept is finished there only. Okay. Now what I need to do in each of this table, I need to create a primary key and foreign key, right? Now let's see. That is about the third rule, right? In that we need to create every table. Every table must have a primary key and it should be connected to other table with a foreign key. Okay, now order details table I have. In this order details table, I need to create a primary key. If you can see my order number, I will have some duplicate values, right? 10104, 10104, I have the same value. Like that, this one also I have same value. So I cannot use this as a primary key, right? Correct. So for that, what I will do, I will create randomly one more column here for this table and I will just write it as order ID. Okay, we can add a tables randomly. It should not affect the whatever columns we are adding here. That column should not affect this data, but we can add something like order ID. I'm just adding order ID column here. So I'm just randomly giving some numbers here: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I just added one column. By adding this column, I have order numbers, order quantity, quantity ordered, sales, like this. but by adding this it is not affecting my any of the data here. And you can see I gave just a unique values for each and every order what I have. So I given that column name as ordered id, and I can consider as primary key here, this column as primary key. Am I right? Actually this column belongs to this table only. Now I just created a new column, I added a new column. Am I clear? We are almost done with the time. If it is clear, please tell me.
Yes, ma'am. Clear.
So for this table, I created one primary key. Okay. In the same way, let's see for products detail table. In products detail table, maybe I need to. 1 minute. I forgot to split this data. We have one more column here. See the same one. For the trucks, this is the product price, right? So I need to keep 80 here. I mean 100 here, and I need to keep what is the another 80 here, right? At that time I forgot about this column. I didn't see this column. Okay. In the same way, trucks I will keep 100 and buses I will keep 80. Product price also it was I had to split at that time, I forgot. Okay. So this is common, right? This 100, and for trucks the product price is 100, for buses the product price is 80. Okay. In the same way I just splitted that data. Okay. Now this is my data basically. Sorry for that, maybe I didn't saw that column at that time. So here you can see I have product code, product name, product price. We need to create a primary key for this also. Maybe we need to continue this in another class. We are done with the time. Is that okay? One last class we will finish this concept.
Ma'am, do we have class tomorrow?
No, that's what I said. We don't have class tomorrow. Both the classes we don't have.
Okay.
Okay. So tomorrow is Wednesday, right? On Thursday, we will finish this concept. Bear with me for one another day. Okay. Let's continue from here only. Try to remember what I said previously. Okay. We need to finish the last rule of 2NF and we need to finish the 3NF. Then we will finish by Thursday this concept and we will start some new concept on Friday. Okay. All right, guys. Let's meet on day after tomorrow. Okay.
Thank you, Divya.
Yeah. Thank you. Bye bye.